So now, this video discusses about what we call as the diagonal trains. And of course, from there, we'll be discussing about what we call as the oxides. So, what is the diagonal trend? Let's say we have a simple periodic table. Let's say sort of this. Let's say we have a simple periodic table that we can have to discuss about. Let's say this is a typical periodic table. And the interest is just on the few actual elements that portrays the diagonal relationship. If we say a diagonal trend, it is the same as the diagonal relationship that the actual elements in the elements in different groups and periods do portrays. Let's say we have this is let's say this is a simple periodic table that you just have to understand. And for the sake of interest, let me just have to have, let's say, just 4 periods will be enough in the structure. And let's say this is a lithium. Of course, this is a group 1, and let's say this is group 2, and say this is group 3, and this is group 4, and so forth. And let's say this is a barium, this is a boron, and let's say this is a carbon. And down here we have a sodium, and we have magnesium, we have aluminum, and this is a silicon. Now we expect that the area actually, now in this case, we should have, by the way, here we have it as potassium anyway, but so now we expect that at the end of the day, according to the principles behind, we expect elements in the same group to portray same or actually a chemical properties. So elements in the same group must have to portray the same chemical properties. So in other words, the way lithium behaves, it is the same way sodium behaves, and also the same way should be that of the potassium behaves. The way barium behaves, the same way magnesium has to behave, likewise as we go down. And also in the same case here, and also in the same case here. And this is only happens if the group if the elements are in the same group. But now there is something you have to understand. It is observed that the way lithium behaves, it is the same way magnesium behaves. Now, since the relationship is diagonal, we call it as the diagonal relationship. So it goes like that. And also the same way barium behaves, it is the same way aluminum behaves, it is like that. And also like that. So this is what we call it as the diagonal relationship, where the actual elements of different groups in the different periods behaves equally in the diagonally. That is what we call it as the diagonal relationship. So keep that in mind. And here is the question for you. Try to search it out. Why do these actually elements relate diagonally? What brought about the diagonal relationship? I want to see the responses in the comment section below in case you have an interest too. But that's how you start to understand about the diagonal relationship. And now let's finish with what we call as the oxides. If we say oxides, these are the compounds, or actually these are the substances or compounds with oxygen atom. We call them as oxides. So these are the actually compounds with oxygen atom. That is what we call as the oxide. We can have, let's say, carbon dioxide. That is also that is the case. Carbon dioxide. We can have, let's say, sodium oxide. That is. We can also, let's say, have nitrogen oxide. So we have different oxides that you have to come across with. But if we say oxides, these are the actually compounds with oxygen atoms. And now we have two types of oxides. We have what we call it as what we call it as the acidic oxides. And we also have what we call it as the basic oxides. So what are basic oxides? So basic oxides. And I also have what we call them as amphoteric, and that should be oxides. We call them as amphoteric oxides. Now, what are acidic oxides, and what are basic oxides, and what are amphoteric oxides? So keep in mind that the elements are classified as being a metal. We can have non-metal, and we have the metalloids. So we have non-metal, and we have what we call them as the metalloids, or we call them as semetals. So oxides that are being formed, I should say the oxides that are being formed from the metal, that's said to be the metal oxides, the likes of sodium oxide. This is a metallic oxide. So oxide formed from the reaction, between the oxygen as well as the actual sodium. We call it as the metal oxide. So when the actual metal oxides dissolves in water, they produces the solution of what we call it as a basic solution. They produces what we call it as the basic solution. So when the metal oxides dissolves in water, they produces the solution, which is a basic solution. So if we say a basic oxides, these are the oxides that when they dissolve in water, they produces a basic, actually a solution. So for that case, metal oxides are the ones that brought about the basic solution. That is to say, if we say a basic oxides, these are the oxides that when they dissolve in water, they produces a basic solution. And basically, these are metal oxides. And how about the acidic oxides? Acidic oxides, these are the oxides that when they dissolve in water, they produces acidic, actually a solution. That is non-metal oxides. These are the oxides formed from the non-metals. And we have what we call them as amphoteric oxides. These are the actual oxides that when they dissolve in water, they produces a solution which is either acidic or basic. That is what we call as the amphoteric. Mind you, amphoteric substance, it is a substance that behaves as an acid or as a base. So amphoteric oxides, these are oxides that when they dissolve in water, they produces a basic solution, and also it becomes that acidic solution. And basically that is for the metalloids, for semi-metal, actually for the semi-metal oxides, that when they dissolve in water, they produces what we call as the amphoteric substance. So keep that in mind. And basically elements in group 1 as well as group 2, they produces what we call as the basic oxide. I should say elements in group 1 as well as the group 2, they produces what we call as should be that of the metal oxide, and they are the ones responsible for the basic oxide. And the elements in group 3 and the bit group 4, they are the ones responsible for the amphoteric oxide. They are the ones that are responsible for the amphoteric oxides, and that when they dissolve in water, they produces a solution with acid as well as the basic. And likewise, group 4, 5 elements, these are typical, and up to 6, and also should be that these are typical nanometals. They produces what we call as acidic solution that is responsible for the acidic oxides. So keep that in mind. So if you can see the periodic table, elements in the far light, actually in elements in the far light end of the periodic table. Let's say this is a typical periodic table. Elements in the far light end of the periodic table, let's say group 1 and group 2. These are metallic actual elements, and basically they are responsible for the actual basic oxides. And the elements in group 3, 4, basically they are responsible for that of the amphoteric substance, amphoteric oxide. And the elements in group 4, 5, 6, 7, they are responsible for the acidic oxides. So that's how you start to understand about the oxides. Oxides, these are the actually substances or the compounds with oxygen atom in them, and they are being classified as they have been classified as the acidic oxides, and that should be the amphoteric oxides and also the basic oxides. So keep that in mind. Now let's have this question: classify the following oxides are as acidic, basic, or amphoteric. So let's have the first case, and by the way, this has to be it has to be stoichiometry, should be a subscript, has to be a subscript there. So we have what we call it as rubidium oxide. So rubidium is a group 1 element, which is the alkali metal. So therefore this is a basic oxide. And barium, this is a group 2 element, and which is alkali earth metal. But now since it also possesses the diagonal relationship and with a group 3 element, then this is said to be the amphoteric. But of course it can be also a part of a basic, or it can be acidic. But now since it portrays the diagonal relationship, it is said to be the amphoteric substance. So that is amphoteric oxide. And we also have what's happening here. That has to be a subscript. And also this is also has to be a subscript as well. That I should have it here. So that is how you should have it. Okay, we should have it something like 5, should be 5 here. So arsenic, this is non-metal. That should be, this is a basic oxide. And let's also have the following questions. And now let's say we have to classify the following oxides as acidic, basic, or amphoteric. So how do you think you can have to classify those? Then that should be, and also you should have to go on question 2 and appreciate. So thank you.